Okay, so let's take a look at parallel circuit worksheet 2 and question 1 here. Um, More branches obviously here, but again, same process. So I'm going to go through, you guys know my method to the madness. I like to label what I do know. I don't know my current in this case. R1 is 4 ohms, R2 is 12 ohms, R3 is going to be 4 ohms. I know there's a typo on that one, so just know that it's R3. And then R4 um, is going to be 12 ohms. And it wouldn't matter however we label these in what order. So we got two that are 12 ohms and two that are 4 ohms. So the first thing that we got to figure out here is our resistance equivalency for this circuit, right? Our total resistance. Um, so you might recall, in order to do that, we're going to start out with 1 over RT is equal to 1 over R1 is 1 over R2 plus 1 over R3 plus 1 over R4. Plug our numbers in. We've got 4, 12, 4. Oh, sorry about that mistake on my part. And then 1 over 12. And so we got to get the same common denominator. So 4 and 12, everything, lowest common denominator is going to be 12. So I got, that goes in 3 times. So 3 times 1 is 3. And then the same thing here. So then you get 3 plus 1 is 4. 4 plus 3 is 7. And 7 plus 1 is 8. So I end up with 8 over 12. I'm going to pull this up here so we can continue. Rewrite it out. And then, as you might recall, need to do the reciprocal here. And so in this case, what we'd want to do is take our calculator. I'd like to use a calculator in this case rather than doing the long math. And we're going to take 3 and divide it by 2. And I end up with 1.5 ohms. Okay. So in here, I'm going to write 1.5 ohms. Oops, sorry. Yep, completely botched that up. 1.5 ohms is what my total resistance is, which means now I can use my formula for current, right? So my current total is equal to voltage over resistance total. So I've got 12 and 1.5 here. So my current in this case is going to be 8, and that'd be 8 amps. So over here, right in here, 8 amps. And then, as I've told you before, I like to check my work. So I'm going to use this formula because I think it's the easiest. And my amps are 8, and my resistance is, or resistance total is 1.5. And if I multiply those two, we get voltage is equal to 12 volts. So now we know that's good because that aligns. Okay. And if you want, I know I typically like to put in my currents like so. So this would be 8 amps coming back and 8 amps going out. Okay. All right. Let's look at another one. All right, so looking at this problem presented to us, um, again, I'm going to label everything. And then, so I got my amperage in there, and then R1, 12 ohms, R2, oh, they're all 12 ohms. Oh, how nice. So you might recall that if we have the same resistances in each branch, right, we can take that number and divide it by the number of branches, so 12 divided by 4, and that would give us 3 ohms, and that's the easy way of doing this. I think for our purposes, I'm just going to walk us through the math on this one, just so we know how to solve for it. So we're trying to figure out, oh, we don't know the voltage. Look at that. I accidentally put that in there, and I don't even know if that's true. Sorry about that. So we have the very first thing we got to figure out is our equivalent resistance so that we can solve for our voltage. So what I'm going to do here, again, 1 over RT as we've done. Like so. All right, so from here, because we got the same denominator, that makes it somewhat easy, right? So it's up being 4 over 12. Reciprocal of that's going to be 3 ohms. Okay, so we know that our resistance total is 3 ohms. So now, if we want to solve for voltage, right? Voltage is equal to amps times resistance total in this case. And sorry, I probably should have used I. I'm not trying to confuse you. I'd write it and I'm not even thinking about it. So I know that here they're using I. So I total in this one. So we got 4 amps times a resistance total of 3. So in this case, 4 times 3 is 12. 12 what? 12 volts. So here would be 12 volts. And if we want to try to just prove that again, we could solve for anything. Maybe this time let's do current. So current is equal to voltage divided by resistance. So plug in our numbers, 12 divided by 3. And so current is equal to 4 amps. And that's what we've got right here. So we know that's a good solution. All right, let's take a look at number 3. Okay, so in question number 3 here, we've got, again, we don't know the voltage, right? So I like to label everything, put my current up here at 1 amp. 1 amp coming back here. And then we've got our resistances, so I'll just plug those in, 2 ohms, 4 ohms, 6 ohms, and 12 ohms. Don't know the voltage, so again, same process as before, right? We're going to solve for the resistance total or equivalency here. So I'm going to write out that formula. So that's going to be 1 over RT R3. We got 4 here, so 1 over R4. And then what I'm going to do is hopefully move this up a little bit. Okay, so now once we got that figured out, plug our numbers in.
6 and 1 over 12. And then when we look at this, we go, hey, what do all those numbers go into? And they all go into 12, right? Let me make the denominator. So 2 goes in 12 6 times, and 4 goes in 3 times, and 6 goes in 2 times, and obviously this one stays the same because it goes in 1 time. So we add that up. 6 and 3 is 9. 9 and 2 is 11. And 11 plus 1, so we get 12 over 12. Or 1 over RT is equal to 1, right? We do the reciprocal of that, so RT is equal to 1 ohm. So now we know our total resistance in the equation. So since we're trying to solve for voltage, voltage would be equal to amps times amps. That doesn't make any sense, does it? Sorry, you get going on these and too many things going on. So current times resistance, in this case, total current, total resistance, the voltage is equal to 1 times 1. So voltage is equal to 1 volt. Now, that's a weird number because we haven't seen it before, right? But let's trust in our math. So we're right up here, 1 volt. Let's go with it, but let's check it, right? So if we go resistance is equal to voltage over current, resistance is equal to 12, I'm sorry, not 12, 1, right? 1 volt. And our current is 1, so our resistance is 1 ohm, right? And if we look at that, that corresponds, that's our resistance total, right? Corresponds to what we solved here. So those two match each other. So that is a good value. We got 1 volt on this unit. Okay, let's take a look at number 4. All right, let's look at this problem. Now we're down to 3 branches again, but again, as I've done before, going to just label everything. Giving me 12 volts. Don't know the current. R1 is 8 ohms, R2 is 8 ohms, and R3 is 4 ohms in this case. So again, I'm going to figure out my resistance total. So, and then we need a common denominator. 4 and 8 will both go into 8. So we don't have to do anything with the first two here. Change this one to 8. 4 goes in 2. 4 over 8. So resistance total is equal to 2 ohms. Now we want to solve for current. So current is equal to voltage divided by resistance total. So my current is equal to 12 divided by 2. So my current is equal to 6 amps. Okay. Now, just going to double check myself, right? So maybe I'll do voltage is equal to amps. Right, I keep doing that. So used to sometimes I'm doing this. Current times resistance. And our current is 6, and our resistance total was 2, and so our voltage ends up being 12 volts. And so that all matches up well, right? So that's good. All right, let's take a look at number 5. All right, so once again, for this question, we're going to label things. We've got 12 volts. We got 4 amps coming around this. And then I got R1 is 12 ohms, R2 is 12 ohms, and R3 we don't know. So we need to kind of figure out what we don't know in this case. We got the voltage, we got the amperage. We need to figure out resistance total, but we don't have the third resistor. So what we want to do, you might recall from before, is we will write out the formula for resistance total is equal to voltage divided by current. And so RT would be equal to 12 divided by 4, which gives us a resistance total of 3 ohms. Okay, so now that we know that, we can go back to our parallel circuit equation like so. And we can start plugging some things in here. So we know our resistance total is 3 in this case. We know that R1 is 12. We know that R2 is 12. And then again, we don't know what R3 is, and that's okay. So now what I want to do is I want to get these alone. So I'm going to subtract 112 and 112 like this. Both of these, right? This one I'm going to over here, and this one also over here. So if I write that, it would be 1/3 minus 1/12 minus 1/12 equals 1 over R3. Now, I'm going to get us some more room here. Let's take this up here. And see if I can get this there. Clean it up a little bit. Sorry, gotta get this just right. There we go, like this. Okay, so one of the things, again, I like to kind of get my equation in order before we start doing anything. We put over here 1 over R3 is equal to 1/3 minus 1/12 minus 1/12. And I need a common denominator. So 3 will go into 12. So we'll make all of these 12. Goes in 4 times, right? Then minus 1/12 minus 1/12, which gives us 1 over R3 is equal to 4 minus 1 is 3. 3 minus 1 is 2. So that will give us 2/12 like this. So 1 over R3 then becomes 1 over 6. And we got the reciprocal of that, which makes R3 is equal to 6 ohms. So over here, this would be 6 ohms. Okay, and we could plug these numbers in by using our already known kind of resistance parallel circuit resistance check, which is what? That's the 1 over RT equal to 1 over R1, 1 over R2, and then 1 over R3. And in this case, what we'll do, we'll plug in our numbers. T is 1 over 12, 1 over 12, and 1 over 6. 1 over RT is equal, and then what are they? The common denominator here is going to be 12. So this will end up being 2 12s over here. And then from there we can add these together. 1, 2, 3 is going to be 4 over 12, right? In this case, and from there we'll end up with 1 over RT, which is equal to 1/3, and then the reciprocal of this RT is equal to 3 ohms. And then from there, right, this number here, right, down here, will match what we had over here, right? So those are good. So our resistance total. So that one makes sense. All right, let's do number 6 and finish this up. Okay, so on this last one, same steps, right? As far as I just don't know my voltage, but I'm going to go ahead and label my current that's coming out of here. Oop, got my highlighter. Wrong tool. So we got on this guy coming out here 2 amps, and then coming back 2 amps. And then we got our resistance values. So R1 is 24 ohms, R2 is 24 ohms, and R3 is 12 ohms. Don't know the voltage, that's okay. So let's figure out our resistance total for this guy. We got 24 and 24 and 12. All right, so now 12, we'll go into 24. So all we're going to do in here is put in our 1 over 24 plus 1 over 24, and then over here, change that to 24, which is 2 24s. So then 1 over RT is equal to what? 4 over 24, which makes this 1 over 6. And then, of course, the reciprocal of that is 6 ohms. So that's our total resistance. Now, once we know that, we can determine what the voltage value is, right? Because voltage is equal to our amperage times our resistance in this case, right? So we've got 2 amps, and we've got a total resistance of 6, which means that our voltage is 12 volts. Over here, we should have 12 volts and 12 volts. So now what I can do, just to double check my work in here, I can use one of the other formulas. Maybe I use current, for example, is equal to voltage divided by resistance. So current is equal to 12 divided by our total resistance was 6, which means that our current is 2 amps, and that of course matches what we had listed right there. Okay, and so that one is sound with that solution as well. All right, hopefully again this was helpful. If you have any questions, make sure you let me know. Thanks everyone. Bye.